welcome everyone. And we would kick off this track with the first talk by Jacob Tomlinson about EffVer.
Awesome. Thank you very much. Hi, everybody. My name is Jacob. I'm a long-time maintainer of various packages within the ecosystem. I've worked a lot on Dask. I work on Rapids at NVIDIA. I kind of contribute to a bunch of things, and I've spent more time than I would like to admit thinking about versioning of packages within that ecosystem. About a year and a half ago, I wrote an angry blog post about this, which has kind of spawned off a whole load of stuff. So that the URL of the grumpy blog post will be at the bottom through most of this talk. But I want to kind of set the scene a little bit by talking about this new magical made-up package that I have. I've just made it. You all love it, right? You've all adopted it. It's a dependency in everything that you're building. The current version of this package is 2.4.8 because, it is. And I've just put out a new version. We changed some things. We merged some pull requests. I've put out a new version. That version is 2.5.0. What can you tell me about the package? Right, using kind of traditional versioning, what can you tell me about this? Feel free to shout out.
There could be breaking changes.
There could be breaking changes.
Like new features.
New features. Anybody else?
Some bug fixes.
Some bug fixes? Yeah, okay. Would you feel comfortable just adopting this package with this version change? How confident do you feel? On a scale of 1 to 10, would you just pick it up? 5?
9.
4? Okay. So this version scheme that I think most people are thinking in at the moment is called semantic versioning, right? This is kind of it has a website. You can go to semver.org. It kind of outlines all of these rules around how to version packages. But mainly you have these three components. The leftmost component is the major version. This is the big scary, everything's broken. You need to do some stuff to adopt this. The middle number talks about new features, right? There's a new thing has been added, a new improvement to the package. And then the last number is like patch, bug fix, security fix, whatever, like small kind of incremental changes. This is great. We use this a lot. And you can kind of mentally group this into a couple of sections, right? If the big number changes, I have work to do. I know I have work to do. There's a new major version. That's a significant event. But Semver makes the promise that if the other two numbers change, you should be fine, right? You can adopt this, right? There's either a new feature or a bug fix. Everything is fine. The package is now better or more correct than it was before. Okay? I don't trust this, right? I've been bitten by this so many times because these things do break you, right? Because just the practical nature of writing software. When you fix bugs, when you do different things, you'll break various people. And there's a law, because there's always a law about these things. But there's this nice law that's Hiram's law, which kind of states that any observable behavior in a piece of software will be depended on or used by somebody. And this is going to be more true for popular packages, right? Like NumPy, you can imagine any behavior of NumPy will be baked into somebody's code somewhere, right? If you have maybe a more obscure package, you can maybe not feel so intense about it. But I think this idea of fixing a bug can break people, right? And there's a nice XKCD about I like to heat my computer up by holding the spacebar. This idea of fixing a bug can be breaking, kind of violates all the rules of semantic versioning. But there's tons of examples happening of this. When I wrote this talk, I grabbed a quick example from Pandas, just because it was a quick thing to go and, very popular, one of those packages that probably every observable behavior is relied on by somebody. And the example that I pulled out, this bug, 52,000 whatever, there was this example where if you take a series of date objects and you convert it to datetime, PyDatetime objects, it raises an exception because they're dates, not date times. Things are sad. But the behavior up to this point in Pandas 2.0.1 is that it raises an attribute error because Pandas wasn't handling this, right? It was trying to access the hour from the date object, and date objects don't have an hour, and so it would raise an attribute error. This has been around for a while, right? And people, quite understandably, had put in try except, I've done a thing, I'm going to catch the attribute error, and I'll do something else with it. That's great, that's how you would handle this. But then in Pandas 2.0.2, so a tiny little bug fix release, this exception was changed from an attribute error to they caught that and re-raised it as a value error, which is correct. It's correct, right? It's a more correct way of doing things. But now all of these people with try except attribute error, their code is now broken, right? And there was bug reports on pandas saying like, oh, upgrading from 2.0.1 to 2.0.2 has broken my package or this or that, right? And this is just kind of a demonstration that, I don't know, we spend a lot of time thinking about arguments that go into a function and returns that come out of the function. We spend less time thinking about all the possible exceptions that can be raised by a function. That's like a very correct thing to do, but we don't necessarily do it because we're busy. But that's an observable behavior that you can break for lots of people. And so it's not a super simple thing to decide what the next version number is. Should that have been pandas 2.0.2 or should it have been something else? Like it was a breaking change. Should it have been pandas 3? Like it shouldn't have been pandas 3. But SciPy is kind of broken in that sense, that if you take it at exactly what is written on SciPy.org, the world is not going to align with that. And so a lot of people in kind of the Python space, scientific Python space especially, spend a lot of time saying, like, is there another way? I'm grumpy with this. I want a different thing. And some packages, including packages I've worked on, they do this instead, right? So instead of saying, my version number is based on these semantics that are well defined, I can switch to calendar versioning, right? This is the new version that's come out on this day. And I've done this. In this new magical hypothetical package we were talking about, I didn't like semantic versioning. I've switched over to calendar versioning. You're all on 2025.7.8. And I've just released a new version, 2025.8.0. Shout out, what can you tell me about this change? Exactly, it's a new version. Can you just blindly adopt this? No. Yes? Exactly. I deleted almost all of the API in this change because I didn't like it anymore. But you can't tell that from the version number, right? And calendar versioning is a thing. It exists. There's good reasons for it and bad reasons for it. We did in Dask, we moved all of our packages over to calendar versioning because we were sick of semantic versioning. And everybody was very sad because just nobody could tell a difference between things. Because often you don't upgrade from one version to the next version. You upgrade from one version to 10 versions later. And like you just haven't, with calendar versioning, you have no idea of what's changed in that interim. There's no meaning or information other than like dates. We actually found a lot of times, like Dask is one of these complex projects where you have a core repo and then lots of kind of satellite projects. The core repo would change some stuff, do a release, and then the satellite projects would adopt those changes later and kind of add those and do a release. And so like this new feature, all the dates would be like staggered as the kind of other projects have adopted. But people wouldn't assume that. They would be like, oh, well, I'm just going to install all the packages from June because I just assume that everything across Dask from June will be fine. And it's like, no, actually, you need like this package from July and this package from August to kind of get all these things lying together. And it's a sad time. And so I get grumpy about calendar versioning because you don't know how much effort it's going to be to adopt a new version. You just have to assume that every version change is going to be hard to adopt. Or at least I'm going to have to put some effort into understanding how hard it is. And you have to do it every single time. There's times where this is okay. Like if I'm training a model, and then next month I'm retraining that model, and next month I'm retraining that model, put a date on it. That's fine. Like the API that you actually call the model with is fine. If I'm making like a distribution of packages or a collection of things or a collection of configuration files, great, put dates on it. There's no, like calendar versioning is not like evil. But for library development, it is not helpful to your users. If you actually go to the calver.org website, they hold up at Ubuntu as this nice example of like this project that uses calendar versioning that's like hugely and widely adopted. But if you've been around in the Ubuntu world, you'll know that there's like a whole bunch of different versions, and there's patterns to these versions, right? They only release twice a year. They do bug fixes in between, but they only release twice a year. Some of these get like long-term support, but they have this pattern of doing April and October releases. And they basically guarantee stability within those releases as they do the bug fixes. But if you want to move to the next big iteration of that version, you consider that like a breaking change. It's a big move. You have to do a migration. If you're a sysadmin or an ops person, like going from one Ubuntu version to another is like an event. And so I would actually argue that Ubuntu uses semantic versioning as well. They just have major and patch. Those are the two segments. It just happens that major aligns with the date. Like, that's fine, that's cool, you can do that. But going around saying, like, this is a good example of why you should use calendar versioning, I don't think holds up, because it's not calendar versioning. I know that Python itself, it's like CPython is talking about doing something kind of similar, where it will be 3.year.bugfix, and like that kind of fits into that same world of they're doing annual releases anyway, and having that middle number be 13 or 26, like it doesn't hugely matter, and if it's aligned with the year, fine. I don't know how much value that adds, but it's still, you're trying to communicate things to people through this version number, and kind of just wholesale calendar versioning doesn't do that. I wrote a grumpy blog post about this as well. This is just kind of highlighting our experience in Dask of going to calendar versioning for libraries, and it's, yeah, not a good time. So just to kind of recap all of this, SciPy is the thing that lots of people assume that everybody's using. It's very popular in lots of places, but it falls apart quickly, especially in open source and kind of community projects that maybe don't necessarily have like the scrutiny that you might think about every single facet of what is breaking and not breaking in a package. I could imagine it being great if you worked internally in an organization on a closed source project that was kind of everybody could keep the whole thing in their head, and there was a bunch of packages related to each other, and you had like really tight, rigid control, and you know, there's a time and a place, and it's totally fine. But I think for this community, it doesn't hold up, and people get grumpy about it. Calendar versioning, for the same reason, like there's good times to use it. But usually for software that you're trying to communicate to people, it's not a great thing to use. So again, is there another way? Is there another thing that we can do in versioning? And actually, if you look at a bunch of packages kind of within the PyData world, the SciPy world, whatever you want to call it, they don't quite do semantic versioning, but they do something roughly similar. And there's kind of like an informal way of doing things. Lots of packages follow the same kind of stuff. And I spent a bunch of time, when I was getting grumpy about Dask switching to calendar versioning, I was thinking about like, how do we explain what we are doing in other packages? Like, is there like a thing? There's no name for it, right? It's like semantic versioning with extra rules or extra stuff. And so again, I like writing grumpy blog posts, and I wrote a blog post, and I called it EffVer. Right, versioning by the amount of effort that it will require to adopt a new version. Instead of trying to tell you, this is a bug fix, this is a feature, this is a breaking change, it just tries to tell you, like, hopefully this won't hurt you, you might want to think about this, or you definitely want to think about this. And I wrote this blog post, and I published it, and I told a few people about it, and started using it in my own projects. And the first project that came to me was some folks from Matplotlib, and they were like, oh, we do this. This is exactly what we do. This is how we reason about all of these things. And so I was like, oh, please put on your README that you use EffVer, because then you have a spec you can point to that's written down somewhere. It can help you reason about what the next version should be. And so they did, which was great, and I appreciated that. And then slowly over time, more and more projects have kind of slowly adopted this and started adding badges. A big one recently was JAX, and thank you, Jake, for doing that, because loads of people now, when I talk to them about EffVer, they're like, oh, new version scheme, I'm not interested in a new version scheme. And they're like, oh, wait, JAX uses it? Okay, fine, maybe it's a real thing. So Matplotlib and JAX especially have kind of given me a lot of, made it a real thing. a bug fix, probably like that pandas one I showed before, that you don't really think anything of it, right? You've gone from something that's incorrect to more correct. You've changed a weird exception that's been raised that shouldn't have been happening. You're raising like the correct exception. That's generated work for a bunch of people by accident. And you kind of wish you had released a different version number, but you probably didn't know that ahead of time, right? And this is something that comes up when we were talking about EffVer to people, is people come and ask, like, what happens if I release a version and then more people are impacted than I thought was going to be impacted by this? Like, what can I do to fix it? Do I need to revert it? Do we need to put in a workaround? And sometimes you sit and think about it, and like, again, in that pandas example, you don't want to revert that pull request, right? The code is now more correct than it was before. I don't want to undo that. I don't want to go back to the weird unhandled exception. Like, handling this exception correctly is the right thing to do. I just didn't tell people the right information when I released it. And so something we do kind of in EffVer packaged projects is, say we've got a commit on main and it's version 2.1.1. Fine. What we can do is we don't actually have to change the code at all, right? We're happy with main. Main is fine. We'll leave main alone. But what we'll do is we'll go back to that earlier commit and we'll just retag that, 2.1.3. Everyone can just upgrade again. They're kind of going back to where they were before, but from like a solver, from a pip or a conda perspective, it will just solve to the newest, highest version, and that's fine. And then I can retag the tip of main again as 2.2.0. So anybody who's done the like pinning where you're like, okay, I'm happy to just accept bug fixes, they'll just be where they were and they won't get broken. And hopefully only a percentage of the community who open the issues were, if it was a really bad change, you want to go to version 3. Maybe, probably not. So the other thing we get asked is, what if I add a feature, right? The weird thing about EffVer that some people take a little while to wrap their heads around is when you're talking about how impacted am I, if I add a brand new feature, right, this huge feature, I've been working on it for months and months, and it adds a whole new section to the API. There's all these new functions, there's new classes, there's new all sorts, but it's perfectly orthogonal to everything that was already there. It doesn't rely on any existing code. I didn't change any existing code. There's just new stuff. I've added a new submodule. That would be, under EffVer, that would be like a small release, like a patch release, right? That's just incrementing the smallest number. And I think people are like, this doesn't make sense, because why would you increment the smallest number for like a giant feature? But the nice thing about doing your versioning this way is you don't have to. You can, what you're trying to do is get people's attention and give them information about what's inside a version. So as well as saying like you're going to have to do work, either none, a little bit, or a lot, you're also saying ignore this version and adopt it blindly, or maybe read the changelog of this version, or you really, really need to read the changelog of this version and spend some time on it than necessary. But there's a balance between signaling like effort against features and other things, right? So it's up to you. But I think the nice thing about EffVer is that this almost feels like a bit of like a failure mode or something, where you want to like over-communicate what you're doing. But that's fine. That's like a safe failure mode. That's better than under-communicating and saying, here's a feature, it's safe to adopt, and people just blindly adopt it, and then everything's broken. Right? It's like a safer failure mode, I guess, than other things. The other thing that comes up sometimes is like 0 dot. Releases. It's very common for people to start at we kind of still strive to communicate some information, right? You could think of this as saying, well, this is 0 dot big effort dot little effort, right? You're still trying to use those two numbers to communicate effort to a certain extent. It might just be that, you know, there's a lot of big effort all the time. But you're at least trying to communicate. And I think a lot of projects do this already. I'm not saying this is anything new, but it's just like trying to write down, like, this is kind of how people behave. And you could even, like, there's nothing stopping you in the Python, you know, PEP 440 spec of having 4 segments to this. So you could just have 0 dot, you know, major minor patch, right? You could have like your full fidelity of EffVer if you wanted to, with a 0 at the beginning to communicate like this is early, and we're probably going to bump the big scary number lots because it's early. Like, that's totally fine. But this can also be helpful as a maintainer, that if you're bumping the large effort number a lot, that's fine. You're in early development, you're changing things frequently, you're kind of being disruptive, but that's okay at this stage. But then you might get to like 0.27, and then this number just starts climbing every time I do a release. It's like, oh, this isn't a big impact. Oh, this isn't a big impact. And you keep going, and you get to 0.27.94 or something, and you're like, oh, that number's got really big. Maybe it's time for 1.0, right? Maybe we're time to move to stability. So this can give you like information in 2 directions to give you like a better insight into where you are. So to quickly recap, like, EffVer is not a new thing. Lots of people have behaved in this way, but it's at least a formal definition of how lots and lots of packages in the Python ecosystem do versioning. And the intent here is communicating to people about the amount of effort that they're going to have to do to adopt a new version, and accepting the fact that when you hit release on a piece of software as a maintainer, you're giving work to a lot of people to do, and they'll benefit from that new version, probably, hopefully, but you are asking them to do work to adopt it. And so by giving them the best information you can, you're being respectful of their time and their use of your project, right? It also gives you like a better way to signal, like, read the changelog or ignore the changelog, and give people the tools to reason about when they should adopt, and give maintainers the tools to reason about whether a PR should be merged, or, you know, sometimes you might see a pull request and think, oh, if I merge this, I have to bump the middle number. Do I want to bump the middle number or not? And is that going to feed back into the code review? Or is it going to bump the big number because this is really, really breaking? Maybe you do. Maybe that's fine. But at least it gives you like better tools to reason about these things, I think. And yeah, like I kind of went over in those slides, it gives you some tools for thinking about early development versions in a more structured way. And it gives you tools for kind of fixing broken releases. So I appreciate all of the projects that have kind of people about EffVer. I think it's good to try and get as many people aware of this so that they can expect, oh, projects use these things, and I know how to reason about these numbers, right? Big, scary change, maybe not so bad change, and I can easily adopt. So hopefully next time I give this talk, there'll be even more logos here, and kind of we'll gradually keep going in this direction of having a well-defined version scheme for almost SemVer, but not quite as it's complicated. So yeah, thank you very much. I think the Q&A is done on Slack, is that right?
So folks in the room, a reminder, if you have a question, please put it into the Slack channel, and we'll be drawing the questions from there. So the first question is from Brigitte, who asks about that example that you had earlier in your talk where you had multiple labels on the same commit.
Yep.
What do you do after 3.0.0? Would you keep releasing 2.1.x for easy changes or keep maintaining multiple branches? And if the latter, how many branches are reasonable?
I mean, I guess that's totally up to the project. I think like the majority of projects don't want to have more than one active branch that you're thinking about. Big projects might go to the effort of backporting fixes to other branches, or if you're like, you know, like I work at NVIDIA, we have Rapids packages, we have lots of paying customers that care about things. Sometimes they'll come to us and say, we're on this slightly older version for these reasons. We're not going to upgrade yet. We're going to upgrade in 6 months, but we need some security fix in this thing. Can you backport it? You know, we're going to pay for the support package or whatever. You go and backport it. That's great. That happens a lot in the corporate world. In open source world, it's hard to like fund that, right? There's like not enough time and attention of open source maintainers as it is, so you might not have the ability to do that, but it just depends on the project really. But I think the majority of people in this space would just keep going on the 3.0.0 line and go from there.
Thanks. Next question is by Mihai. How does EffVer work with version resolution algorithms? In Python, saying in Python saying the version's bigger than 2.3.0 would install 2.3.6 if that's the latest, but Go, which uses a different algorithm, greater than 2.3.0 would mean that 2.3.0 is always selected.
Yeah, so I think one of the intents of this is that we kept the numbers and the magnitude of the numbers the same as semantic versioning. Like calendar versioning gets messy, right? Like if you've used calendar versioning in Go, you're in for a bad time, like the way the solver works. We do this in Dask a lot. We have some Go code in there, and every January we have to do a release because the like big number has changed and Go is sad. This question is referring to like the fact that Python will solve to the like highest possible versions of everything, and Go will solve to the lowest possible versions of everything. But with the tagging stuff, it will still work the same way, right? Like with the multiple tags, you'll either solve to the highest one or the lowest one. You're just trying to avoid the middle one, which is technically the broken one. You could also yank if you wanted to go that far and go to PyPI and just pull that version back out again and just leave the two either end versions.
Next question by Ed, what approaches do maintainers have for understanding how much effort a change will require from users as perceived by the users? Are there best practices to prevent the appearance of a pitchfork mob?
It's a good question. I mean, I think a lot of it is hard, and that's why this is a problem, right? Understanding the impact of the pull requests that you're merging is, you know, it's a difficult thing to do. And without like, you know, hopefully you're like using your own packages and then maybe have an idea like yourself of the impact of these things. But having a good communication channel with your community, seeing what people are doing, maybe having code you can run. Like in Dask, we run like a load of X-ray stuff every release because it's like we know they're a downstream consumer of Dask and we want to make sure we haven't broken all their thing. Like there's lots of stuff you can do to do that. But I think that one of the core premises of EffVer is accepting that this stuff is hard, it's easy to get wrong, we're all humans trying to communicate to other humans, and it's messy. And so it's okay to make these mistakes. You just need a route to like fix those mistakes.
And question from Angus, would you be interested to add language on EffVer about the importance of versioning being a social contract, i.e. version numbers can't really exist in isolation?
I mean, yeah, that would be good. I mean, so my blog is a GitHub repo, so if anybody wants to like tweak and extend this. I did actually buy the effver.org domain the other day because it was like, maybe I'll move this to like a separate thing if enough people are using it instead of it just being like a random blog post, and then it could be more of a community-driven spec. But yeah, it's totally a social thing. I mean, I don't know, maybe agents writing all of our code changes that. But at the moment, like version numbers are for humans talking to other humans about software, and it's an imperfect art. So yeah, social contract is a good way of describing it.